Hi guys, Mr. Lead here. Today we're going to continue looking at the topic of electricity. Now, what's been covered prior to this lesson are the different ways you can measure electricity. Now, just like the idea of measuring water, there is no one way of measuring electricity. What you have to do is measure a component of electricity, say current, voltage, or resistance, for example. So current, this is all recapping, current is the rate at which electrons are flowing through a circuit. So that's how many electrons are going past a certain point in a given time. Voltage is the difference in charge between 2 points. Another way of looking at voltage is it's a measure of how much energy individual electrons have. Resistance is a force that opposes current. It's whatever's trying to slow down the current so that electrons find it harder to get around the circuit. And high resistance will therefore mean a low current. Okay, now to test the understanding a bit further, here we have a circuit with a 3-volt battery. The question is, if we've got the current at this state with the 3-volt battery, if we add another 3-volt battery in, so we've got a total of 6 volts, will the current increase or decrease? So to test this, I've got this simulation online called PhET. And the brilliant thing with PhET is that we can see the electrons going around. We can see the current. We can see how fast these little guys are going around. And if I was to tick the little values button here, that means I know how much voltage this battery is providing. So the current of this circuit, according to this ammeter, is currently 1.5 amps. That's the current, the rate at which the electrons are flowing through. So let's see what happens when we add another battery in. Now have a guess, is the current going to increase or decrease from 1.5? It increases to 3 amps. So when you have more voltage, you're giving more energy to the electrons, and they're going to go through at a faster rate. So that answers this question. The current will increase. Next one here, though, is a circuit has a battery and a light bulb with a resistance of 2 ohms. If you add another light bulb, would the current flowing through the circuit increase or decrease? So adding another light bulb, is that going to cause the rate to increase or decrease? I think you might be able to guess, but let's check. So let's just first remove this battery. So current is currently 1.5 amps. Let's add in another light bulb. Here we go. It's now 0.75 amps, and you'll see the electrons are traveling through so much more slowly. All right, so that shows that adding in more components increases the resistance, thus decreasing the current, makes it slower. Okay. So those are the 3 components of electricity that we're going to look at, and you'll notice that these 3 components are very dependent on each other. You know, the current increases when the voltage increases, the current decreases when the resistance increases. They relate to each other a lot. The way in which they relate to each other, the way in which these 3 components relate to each other, that is the focus of this lesson. And we can measure how they relate to each other using Ohm's law. So Ohm's law is this equation right here, named after the German scientist George Ohm. So Ohm's law shows the relationship between current, voltage, and resistance. We represent voltage with a V, resistance with an R, and current we represent with an I. If you're wondering why it's an I, it's because the guy who discovered current was French, and it's a French word, so you didn't get C. Anyway, so here let's do a example equation here. So we have a circuit here with a voltage of 9 volts and a resistance of 2 ohms from this little light bulb here. So the question is, what is the current going around in this circuit? We want to find out the current of this circuit. So we take the voltage and we divide it by the resistance. So we go 9 volts divided by, what's the resistance in this circuit? 2 ohms. That's the symbol for ohms. And that gives us 9 divided by 2, 4.5 amps. So just a reminder, V is the unit of volts, and ohms is represented by the omega symbol, and amps is the unit for current, and that's represented by an A. Okay, so here's another circuit. Again, we want to figure out what's the current of this circuit here. So we do the same thing. We take the voltage, which is 9 volts, and we divide by the resistance. Hang on. There's 2 light bulbs here. We've got 1, 2. So what's the total resistance of the circuit? That's right, it's just 4. 2 plus 2 ohms is 4. So 9 volts divided by 4 ohms, well, come on, 4 ohms, would help if I had a stylus, equals 2.25 amps. You are allowed calculators on the test, by the way, so if you didn't work that out immediately, don't stress. Okay, here we've got another situation where this time we actually know the amps. It says here there's 7 amps in this circuit and there's 5 amps in this circuit. So the unknown thing is the voltage. We want to figure out what the voltage is. Now, that's a bit trickier because the current, the amps, that was all on its own, but the voltage is up here. So if you're well enough familiar with mathematics, you'll know that to get the V by itself, you need to times both sides by R. So that kind of looks like this. So we go times R, I times R. So that means we cancel. Okay, so V equals I times R. So I, R equals V. So that means we just need to take the current and times it by the resistance. Now, if you're not as familiar with mathematics, this whole section here would have just completely confused you. And that's totally fair. So here's the tip I'm going to give, the little trick to be more familiar with this whole V equals IR thing and knowing how to find the unknown variable. Draw this triangle. Draw this triangle. That's it. That's the tip. To be more familiar with Ohm's law and to work out those sort of equations where you need to work out voltage or current or whatever, draw this triangle. See, what this triangle shows is if you're, I'll just explain it here. If you're wanting to work out what the voltage of a certain circuit is, you cover up the V. There we go. You cover up the V. What you're left is I times R. I is next to R, so I times R. If you want to work out what the resistance of a circuit is, you cover up the R. So then you're left with V divided by I, because V is on top of I, like a fraction, V over I. So V divided by I gets you R. If you want to work out the current, you cover up the I, because I is current. You go V divided by R, voltage divided by resistance. Again, fraction. That is how you work out things with Ohm's law. Use this triangle, it will be a lifesaver. At the start of a test, draw that little triangle in the top right-hand corner. So, using that knowledge, if we want to work out what the voltage is in this circuit, we've got to cover up the V. So it's an I times R. Current times resistance. So let's try that. Let's try that for this first one over here. 5 amps times 2 ohms. Very messy, but you get the picture. It is 10 volts. That's the voltage that this battery is providing. All right, this unknown battery over here, what is it providing? We go 7 amps times 4 ohms. That gives us 28 volts. Again, you can use your calculator if you want. Last worked example here. All right, so we now know the voltage this time. We now know the current this time. What was unknown is the resistance. How much resistance is in each of these circuits? So to do that, that's right, we've got to cover up the R, and that leaves us with V and I. So voltage divided by current gets you resistance, because see the V is on top of the I. Okay, so let me just clear up a few of these things. All right, so maybe you're able to work ahead a bit here. 9 volts divided by 0.5 amps. Again, you're allowed your calculator. That equals 18 ohms. Okay, so that's resistance there. Last one, 15 volts divided by 3 amps. That gives you, what's that, 5 ohms. Okay, and there you have it, folks. So that is how you work out the current, voltage, or resistance in a circuit. As long as you know 2 of those variables, you'll be able to figure out the third. Thanks for watching.